Hi everyone. This screencast is going to be about how we sketch exponential functions. So I've got a function here that we're going to use as a demonstration. Y equals -4 multiplied by 3 to the power x take 5 plus 8. So we're going to take a three-step approach. The first step, we will find the y-intercept by setting x equal to 0. So here we go. Let x equal 0. It's always worth writing this down as part of your working to communicate your ideas. So we're going to substitute 3 to the power of 0 take 5 plus 8. So a negative index, this is 3 to the power -5, really means divided by 3 to the power of 5 plus 8. Now 3 to the power of 5, that's a rather big number, so we're going to use our calculator to work that one out. Here we go. So -4 over 3 to the power of 5 plus 8. Oops, that's not correct. I need to move out to the side there. Plus 8. That looks better. And I get a lovely fractional number, which I can change to a decimal, 7.98. Not terribly surprised to see that that's a very close, 7.98. Not terribly surprised there. And I will make a quick note that I rounded that off, so this is approximately 7.98. You see, when we have a denominator with a high exponent like this, we've really got a large value in the denominator, and that produces a very small number for the fraction. So a small negative number, a tiny bit lower than that. That's our first step. Our second step, as you can see over here, we're going to find the x-intercept by letting y equal to 0. Again, communicate your thoughts by making a brief note of what you're doing, rather than just jumping straight into the equation. So I will be having -4 times 3 x to the power my x minus 5, so -4 by 3 with the power of x minus 5 plus 8. So we need to solve this one. I'll transpose the entire first term, leaving positive 8 on the right hand side. Dividing by 4, I have 3 to the power of x take 5. Dividing through by 4 equals 2. Now we're at the point where we have the pronumeral x as part of the exponent. We have a single exponential function, a term here, a base with a power, and we have a number. This is the time to change to logarithmic notation. So the base we're using is base 3. We are looking for the logarithm of the number 2, and the exponent is x take 5. Exponent and logarithm mean the same thing. So this reads logarithm equals what was the exponent in the previous line. On our calculator, you will remember, in order to do this, we have to use common logarithms, base 10 logarithms. So we have to perform the calculation like that. Now let's just get that calculator back. Where did it go? Here we are. So I want the common logarithm of 2 over the common logarithm of 3. Gives me decimal 631. 0.631, add 5, and that's approximately equal to x. So I'm pretty sure I can do that one without a calculator. 5.631 is the x-intercept. That's nice. Now for the asymptote. For the asymptote, we have to consider what happens as x approaches positive infinity and as x approaches negative infinity. In other words, as we move a long way to the right or a long way to the left across the graph. So there's my function. I'll first check out what happens with positive infinity. So here we go. So as x approaches positive infinity. Y will be given by negative 4 by 3 to the power x. Now I can't write infinity because there's no such number. It's an idea. Minus 5 plus 8. If I want to get an idea of what's happening here, I can't use, there is no infinity key on the calculator, but I could just substitute a large value. Better still if I substitute a couple of different large values. Now I might start with a number like 10. I know that's not particularly large, but it's a starting point, plus 8. So that's a fairly large negative number. Now let's go up here and change this to be an even bigger power, and that's an even larger negative number. We're in scientific notation now. 10 to the power 45 means moving this decimal point 45 places to the right. That is a stupendously large number. So I think we can see that as x approaches positive infinity, this one might go beyond, yes, it's too large for the calculator, that one. That's okay, we can get the idea. As x approaches positive infinity, y is given by this formula, and we've just noted that y is approaching very large negative numbers. That doesn't seem like asymptotic behaviour. Now let's check what happens as x approaches negative infinity. Again, there's my equation. So I'll get the calculator back and we'll try a few different sized negative values for x. So if I go back up a bit, I might be able to replay. There we go. So let's pop a value of negative 10 for x. So I'm only going to end up with 3 to the power of negative 15. Again, that makes the denominator a large number. And that seems to be getting pretty close to 8. Remember last time when x equals 0, we were very close to 8. We're even closer to 8 now. If I make that negative 100, we're pretty much exactly 8. So it seems like if I was to make that, at the risk of causing another error, nope, that one was fine, it's also 8. It seems like when x moves to the left, y, oh, sorry, didn't mean that to be red. That's just my mistake there. So y seems to approach the value positive 8. That definitely is an asymptotic type of behaviour. Well, time to sketch the graph then. So I will have my x and my y axis, of course. Don't forget to put a label on the positive end of each axis. Now, we thought that the asymptote was when y equals positive 8, so I'll put a nice little dotted line across here and label this y equals positive 8. Remember, a horizontal line is of the form y equals a constant. Then my x-intercept was at 5.6, so x-intercept over here somewhere, and that's 5.60, and our y-intercept, I remember, was really, really high up there. It was 7.9, I think, from memory, 7.98. So here we go, 7, beg your pardon, x value goes first, so x coordinate 0, y value 7.98. Now I've got a graph here that is, as I go to the left, approaching but never quite reaching the value here of 8. So it'll be crawling along here, then I'll be taking a bit of a sudden nosedive down here and going downwards forever. And it will go this way forever as well. And there's the sketch of my graph. Now the very final thing I would like to do would be to just confirm what I thought by popping this into the online graphing app Geogebra. So negative 4 multiplied by 3 to the power of x take 5 plus 8. There we go. Not too sure why there are dots there. But as I come across here, we can, if I click on the function, there it is. Well, it said Y-Intercept is 8, but it's not quite, it's just below. That's because Geogebra is, for some reason, only giving me one significant figure there. So if I come back out, again, click on the green line, and I can check that one, 5.6 as we expected. So that all worked out very nicely, and that's how we sketch exponential functions. Thanks for watching.